This will start the lecture notes for Section 3 of Chapter 2. And Section 3 deals more with forces than motion. And first part asks, what is a force? And very simply, a force is a push or a pull. Sometimes it's obvious that a force has been applied, but other times other forces aren't as noticeable. A force can cause the motion of an object to change. And an example is if you play billiards or pool, you know that you can force a ball at rest to roll into a pocket by striking it with another ball. The force of the moving ball causes the ball at rest to move in the direction of the force. Force does not always change velocity. When two or more forces act on an object at the same time, the forces combine to form the net force. It's just like saying that I better use a better marker here. A plus B, equals, I don't know why that does that, A, B. This would be the net, or the total, so that this force plus this force combined produce the net force. Net force on the box is 0 because the two forces cancel each other out. And in the example shown here, the graphic, because the two girls aren't moving the box, their net force is 0. Forces on an object that are equal in size and opposite in direction are called balance forces, or if they equal 0, they're balanced. When two students are pushing with unequal forces in opposite directions, a net force occurs in the direction of the larger force. Here's an example of that. The net force that moves the box will be the difference between the two forces because they're in opposite directions. The girl is stronger than the boy in this case. She's able to push the box in this direction, so these forces are unbalanced and she'll overcome his force. Students are pushing on a box in the same direction. These are also unbalanced forces. These forces are combined or added together because they're exerted on a box in the same direction. Net force that acts on this box is found by adding the two forces together. Not that difficult to understand forces. Inertia is a tendency of an object to resist any change in its motion. If an object is moving, it'll have uniform motion. It'll keep moving at the same speed in the same direction unless an unbalanced force acts on it. Velocity of the object remains constant unless a force changes it. If an object is at rest, it tends to remain at rest. Its velocity is 0 unless a force makes it move. The inertia of an object is related to its mass. And remember from the quiz we had an example that a bowling ball will be harder to stop than a soccer ball because it has more mass and therefore greater inertia. And this leads to Newton's laws of motion. British scientist Sir Isaac Newton was able to state rules that describe the effects of forces on the motion of objects. These rules are known as his Newton's laws of motion. Newton's first law of motion states that an object moving at a constant velocity keeps moving at that velocity unless an unbalanced net force acts on it. And a classic example is shooting a rocket into space, because space doesn't have any resistance. There's no air, no other forces acting on a rocket unless it comes into like a moon or a star's gravity. It's going to keep going at a constant velocity forever. If an object is at rest, it also stays at rest unless an unbalanced net force acts on it. This law is sometimes called the law of inertia, Newton's first law of motion. Law of inertia can explain what happens in a car crash. When a car traveling about 50 kilometers per hour collides head-on with something solid, the car crumples, slows down, and stops approximately 0.1 second. Any passenger not wearing a seatbelt continues to move forward at the same speed the car was traveling. in about 0.02 seconds, or 1/50th of a second, after the car stops. Unbelted passengers slam into the dashboard, steering wheel, windshield, or the backs of the front seats. Force needed to slow a person from 50 kilometers per hour to 0.1 seconds is equal to 14 times the force that gravity exerts on that person. And examples you may have heard of, like mothers with babies and taking them out of car seats and say, oh, I can hold on to the baby. It's not going to happen. That baby's going to come flying out of your hands in a crash because, as this says, 14 times the force of gravity. Belt loosens a little as it restrains a person, increasing the time it takes to slow the person down. This reduces the force exerted on a person. Safety belt also prevents a person from being thrown out of the car. Airbags also reduce injuries in car crashes by providing a cushion that reduces the force on the car's occupants. When impact occurs, a chemical reaction occurs in the airbag that produces nitrogen gas. Airbag expands, deflates just as quickly as the nitrogen gas escapes out of tiny holes in the bag. And that concludes the lecture for Section 3. The big thing we want to get you there are the net force, a balanced force, an unbalanced force, and of course Newton's first law of motion. Again, so that I know you've listened to the lecture notes, answer the 3 questions that we're into right here. Question number 1 says a force is a what? Come up with the answer and post your response in the assignment block on your My Big Campus account. Question number 2. When are forces on an object balanced? And question number 3, what is inertia? The tendency of an object to resist any change in its motion, or the tendency of an object to have a positive acceleration. Or choice C, the tendency of an object to have a net force of 0, or letter D, the tendency of an object to change in speed or direction. And again, this concludes the lecture for Section 3 and Chapter 2.